All right, welcome everyone. This particular lesson is on direct variation, so why don't we go ahead and begin. So we're going to go ahead and we're going to start with what we already know and what we're going to be learning in this particular lesson. So previously what we've done is we found rate of changes for linear equations and slope, and so that was in previous lesson. And so now what we're going to be doing is we're going to be writing and graphing direct variation equation. So let's go ahead and get started. So our vocabulary words are direct. I will explain a little bit. That's the type of equation we'll be doing. The variation, and I will also explain that. And then they also have constant of proportionality. I can tell you I don't ever recall a time ever using that term, but you should know that the constant of variation and constant of proportionality are exactly the same. So just a heads up on that. So let's go ahead and move on to the next slide. Okay, now they talk about finding a constant of variation, a slope and constant of variation. Here's what you need to know. We're just going to unannotate for just a moment, go to a blank screen, and what I want to type in here is just a little bit of terminology. So a direct variation equation um, basically, a direct variation equation is an equation that's in the form of y equals x. So I'm going to take that off and I'm actually going to write. So let's just hop into that and that might be a little easier. So basically it's an equation of the form that y equals k times x. What you need to know is that k cannot be 0 and that k is called your constant of variation. Okay, I'm going to show you how to graph these equations. I'm going to show you how to write these equations. Um, and how to get different information just from these equations, okay? So the first thing we want to do then is we want to go back to our desktop. Okay, and so our first example is they give you a graph. So the first thing we're going to do is going to tell from a graph. All right, and so they give you a graph. They ask you to name the constant of variation for the equation, and then they ask you to find the slope of the line that passes through the points. Here's what you need to know, all right, is that the equation is y equals 2x. Now, here is your equation. Remember, our formula was y equals kx. So here you should deduce that k is 2. So k is your constant of variation, so it's 2. Now, what you should also know is that the number in front of x is also the same thing as the slope, which in this case means that your constant of variation and your slope are the same. Therefore, k is 2, slope, we'll use the letter m. M is also 2, okay? And so literally, you don't need the graph. As long as you have the equation, you can pick them both out. Now, the other thing I didn't mention that you do need to keep in mind, when we write this equation, there is never a number after it, so it's plus 0. So that'll come in handy later when we're starting to graph. So let's go ahead and then let's clear this. We're going to do that. And then we are going to, now you could have used the two ordered pairs to find the slope, but you'll find that the slope is the same thing. So constant of variation is 2 and the slope is 2. Okay, we're going to pause for just a moment here. And okay, just a heads up. Let's look at T. Claywood. and see if you guys are doing the same thing, because we're in a lockdown. They should be too. And it doesn't look like it. Okay, well, anyway. Okay, so now that we've done that example, let's go on to the next one. Okay, so now again, I've given you another graph, and so that's going to be y equals kx. And so our equation is y equals negative 4x. So hopefully you see that k is negative 4 and m, or the slope, is also negative 4. Remember, we talked about those being exactly the same. Okay, and so let's clear this and go on to the next piece. I'm going to move this over here. I have no idea why it's doing that, but okay. So there you go. So again, if you do the formula, you'll find out that's negative 4 and they're the same. So hopefully what you've seen is that it's very easy to tell if you already have the equation. So take a minute, read this one, get the answer. You can pause it, and then you can come back and we'll keep going. Okay, so now that you've had a chance to look at it, you're naming the constant variation and the slope of the line. Remember that they're the same. Here's the equation right here, which means what? It's 4. Okay, so when we look, we pick out our answer, and it should be B. So hopefully you got that okay. All right, let's go to the next one. And again, same thing. Here's your equation. Pause it. Give yourself a minute. Okay, and now you'll see what the so hopefully that's working for you pretty well. Now, let's look at actually graphing these equations. So I'm going to walk you through with the example that they have that you see on the screen. So first thing you need to know is that your slope is m, so it's the number in front of the variable. All right. In this case, remember, slope and constant variation are the same, so it's k, so rise over run. And so what you're going to do is you always start at the origin, so you're going to graph this point first. And then this is negative, so that means we're going to move down 3 and then to the right 2. And you're going to see that on when I click that they went down and then to the right. If it's negative on the y, which is always on top, you either move down if it's negative, up if it's positive. If it's on x, right if it's positive, left if it's negative. Now the negative can be top or bottom, it really doesn't matter. I generally always do mine on top, but there's nothing special about that, okay? So then you draw that second dot. Once you come down from the origin, go down and to the right, and you draw that second dot. Then all you do is draw a line connecting them, and you're there, okay? So let's go on and do another one. And there you go. There's your line. Okay. So now take a minute, and we'll pause it, and then you can see if you can get that, okay? Now, keep in mind that your 2 is the same as 2 over 1. So that means you're moving up 2 and then to the right 1. So again, we're going to pause it